Today, we'll be solving LeetCode 34, find first and last position of element in sorted array. This is a medium-level problem, and it is very popular because it combines binary search with range finding. The goal is simple: we are given a sorted array of integers, and we need to return the first position and the last position of a given target value. If the target is not found, we return -1 and -1. Now, the key here is that the array is sorted. Whenever we see sorted arrays and the problem asks for something faster than linear search, that is a strong hint to use binary search. The requirement is that we must solve this in O of log n time complexity, which also confirms that binary search is the right approach. So, what's the idea? Normally, binary search finds just one occurrence of the target, but here we need both the first occurrence and the last occurrence. To handle this, we can run binary search twice, once to find the left boundary, which is the first position of the target, and once to find the right boundary, which is the last position of the target. Let's carefully walk through how we do this in code. We define a function that takes two inputs, the array of numbers and the target value we are searching for. Inside this function, we create another helper function that performs a modified binary search. This helper takes the array, the target, and a Boolean flag that tells us whether we are looking for the left boundary or the right boundary. Here is how this helper works. First, we set two pointers, left equal to 0 and right equal to the last index of the array. Then we also create a variable called index, and we set it to -1. This variable will eventually store the position where we find the target. While left is less than or equal to right, we calculate the middle index by taking left plus right divided by 2. Then we check the value at that middle index. If the middle value is less than the target, that means the target must be to the right, so we move left to middle plus 1. If the middle value is greater than the target, that means the target must be to the left, so we move right to middle -1. If the middle value equals the target, we set index equal to middle. But now comes the key part: if we are looking for the left boundary, then even though we found the target, we keep searching on the left side, so we set right equal to middle -1. If we are looking for the right boundary, then we keep searching on the right side, so we set left equal to middle plus 1. This way, we do not stop at the first match, but we keep moving until we find the extreme boundary. Once the loop ends, we return index. If index never got updated, it will stay as -1, meaning the target was not found. Now, back in the main function, we call this helper twice. First, we call it with the left boundary flag set to true to get the first occurrence. Then we call it again with the left boundary flag set to false to get the last occurrence. Finally, we return both results in an array. The time complexity is O of log n because each binary search takes logarithmic time, and we only run it twice. The space complexity is O of 1 because we only use a few variables. This problem teaches us a very useful binary search pattern, which is searching for boundaries. Instead of stopping as soon as we find the target, we keep moving either left or right until we lock down the exact position of the first or last occurrence. This pattern is common in range-finding problems and is a key skill for interviews. And that's how you solve LeetCode 34, find first and last position of element in sorted array. Thank you for watching, and let's keep learning.